In this video, we're going to be talking about rationalising denominators. And if a fraction has a surd in its denominator, and we talked about surds in the previous video, then it's sometimes useful to rearrange it so that the denominator has a rational number. And a rational number is any number that can be expressed as a over b. And that is what is known as rationalising the denominator. So let's look at an example. How would we rationalise the denominator of the following? 1 over the square root of 3. Now, when we have a fraction in this form, we want to multiply the numerator and the denominator by the surd itself. So we can rewrite this expression as 1 multiplied by the square root of 3 over the square root of 3 multiplied by the square root of 3. Okay? So we're literally just taking our surd at the bottom and multiplying both sides by that number. And if you remember from the previous video, we know that if we multiply two surds together, that is just the same as the following. So that would equal 3. Square root of 3 multiplied by the square root of 3 is 3. And we can also prove this by rewriting our surd here, which is the square root. So 3 to the power of a half is the same as the square root of 3 multiplied by 3 to the power of a half. And when we're multiplying two numbers with the same base to a certain power, we just add together the powers. So half plus half is 1, which is equal to 3. So the square root of 3 multiplied by the square root of 3 equals 3. And 1 times the square root of 3 is just the square root of 3. And that gives us our final answer. So let's look at another example. What happens if we have 1 over 3 plus the square root of 2? How would we rationalise the denominator here? Now, when we have a setup like this in the denominator, we want to multiply both sides, the numerator and the denominator, by the same thing, but we want to change the positive, the plus, to a minus. So we're going to multiply the top by 3 minus the square root of 2 and the bottom by 3 minus the square root of 2. Okay, so let's rewrite that expression now with both sides multiplied by the relevant sum. So we're going to have 1 times, and I'm going to put this in brackets to make sure that we can see it split up. And I'm going to actually highlight for you now that this is meant to be a negative sign. So 3 minus the square root of 2 over, and we take our first sum, which is 3 plus the square root of 2. And then, of course, we're going to multiply that by 3 and then minus the square root of 2. So we can now see how we've multiplied both the numerator and the denominator by 3 minus the square root of 2. Okay, and so now we just want to simplify this equation. So we can simply say that 1 times 3 minus the square root of 2 is obviously just 3 minus the square root of 2. Now 3 multiplied by 3 is 9, it's pretty straightforward. 3 times minus the square root of 2 would be minus 3 square root of 2. Plus 3 square root of 2. Let's just extend this out a bit. And then we got the square root of 2 times by minus the square root of 2. Now, as we just saw, if we multiply two surds together, we just get, well, two of the same number, two square roots of the same number, we just get that number as our answer, which is 2. But obviously it's a negative sign, so we get minus 2. Okay? And then we can obviously simplify this down even further, and that is the whole point, because we're rationalising the denominator. We don't want any surds left in the denominator, and we can see that plus 3 square root 2 minus 3 square root 2 can just be cancelled out, and obviously 9 minus 2 is 7, and so that gives us our answer of 3 minus the square root of 2 divided by 7. And as we'll see, the same principle applies when we have a surd in both the numerator and the denominator. So let's have a look what I mean by that. So if I have the square root of 5 plus the square root of 2, and then that is all over the square root of 5 minus the square root of 2, what do you think we're going to do here? Well, as we just did, we're going to multiply the numerator and the denominator by 5 plus the square root of 2. So let's just write that out. So we've got 5 plus the square root of 2. Oh, that's not correct. 5 plus the square root of 2. And then we've got the square root of 5 minus the square root of 2. Okay. And then on the bottom, sorry, that's actually not correct. Remember, we've got to multiply both by the opposite sign to the denominator. So here it's a minus, so we want the square root of 5 plus the square root of 2 multiplied on both sides. So here we got the same number on top, and on the bottom we got 5 minus the square root of 2, and then we got the square root of 5 plus the square root of 2. So you can see here how these symbols, this symbol and this symbol, is opposite to this symbol over here. Okay, so that's us rewriting the expression to how we want to attack it. And so now we're going to try and simplify this down. Okay, so the easiest thing to do would just be to start from the numerator and then tackle the denominator. So the square root of 5 multiplied by the square root of 5 is just 5. Square root of 5 multiplied by the square root of 2 would be the square root of plus square root of 5 square root of 2, and then we've also got the same thing again. Square root of 5 multiplied by the square root of 2 is square root of 5 square root of 2, and then the square root of 2 multiplied by the square root of 2 is 2. Okay, and then that is our numerator, and then on the denominator we got the square root of 5 multiplied by the square root of 5, which again is 5, and then here we got the square root of 5 multiplied by the square root of 2, which gives us our positive 5 square root of 2. So we've got almost the same thing going on, but now we've got a negative symbol. We can now get negative square root of 2 square root of 5, and then square root of 2 times square root of 2 is 2, with our negative sign is minus 2. And that will then allow us to break this down even further. And to do that, all we need to do is obviously take our 5 plus 2, which equals to 7. Very basic maths there. And then with our surds, to break this down, we know that the square root of 5, actually let me do this in a different colour just so that you can see that clearly. And I'll just do it here for the second. The square root of 5 multiplied by the square root of 2 is just simply the same as saying the square root of 5 times 2. So that will equal the square root of 10. Okay, so we can then say, if I get rid of that now, that we have in our numerator up here, the square root of 10, plus the square root of 10. Okay, so we've now got two of these, so we've got 7 plus 2 square roots of 10, and then in the denominator, we've got 5 minus 2, which is 3, and then plus 5 square root of 2 minus square root of 2, 5. They will just cancel out, and then that will give us our final answer. So let's look at one final example. So if we have 1 over 1 minus the square root of 3 squared, what do you think we're going to do? Now, if we work through this logically, it shouldn't be too much of a problem. So why not give it a go yourself, and when you're ready, continue with the video. Now, the first thing that I would do is rewrite the expression in a form with which we are familiar. So 1 minus the square root of 3 squared is the same as saying 1 minus the square root of 3 multiplied by 1 minus the square root of 3. And we can therefore simplify this into the following. Well, 1 times 1 is 1, minus the square root of 3 multiplied by 1 is minus the square root of 3. And then we've got 1 multiplied by minus the square root of 3. So again, we've got minus the square root of 3. And then we've got minus the square root of 3 multiplied by minus the square root of 3. Now we know that the square root of 3 times the square root of 3 equals the square root of 3 times 3, which equals the square root of 9, and the square root of 9 equals 3. But obviously we've got two negative numbers and they make a positive, so we've got 1 plus 3 there. And we can simplify this down. Obviously 1 plus 3 is 4, so let's just put that in place there. And we've got 4 minus the square root of 3, the square root of 3. And again, we've got two square roots of 3, so we can just say 4 minus 2 square root of 3. Okay, so that has brought us to a nicer position because we can now rationalise this as we've done with the previous examples by multiplying both sides by this expression but changing that sign to a positive. Okay, so let's do that now. So if I just get rid of the top half and just keep that there for our sort of reference, we know that we want to write out 1 multiplied by 4 plus 2 square root of 3, all of that over 4 minus 2 square root of 3 multiplied by 4 plus 2 square root of 3. Okay, so that's now our new expression that we want to use. We've multiplied both the numerator and the denominator by 4 plus 2 square root of 3. And now all I want to do is to rationalise this further. So I'm going to get rid of this expression now, and we're going to simplify this. So this is the same as going 4 plus 2 square root of 3, because of course 1 times that is just that. And then let's just make this bigger because this is going to be a slightly longer expression. And we know that we can have 4 multiplied by 4 is going to be 16. And then we've got 2 square root of 3 times by 4, that equals 8 square root of 3. And we've got 4 times minus 2 square root of 3 is minus 8 square root of 3. And then we've got minus 2 square root of 3. Let's just do this over here so we can just see what I'm doing now. So we've got minus 2 square root of 3 multiplied by 2 square root of 3. Okay, and when we got a situation like this, all we want to do is let's think about this in stages. So we've got minus 2 times 2 is minus 4, and we've also got square root of 3 times the square root of 3, and we knew that the square root of 3 multiplied by the square root of 3 equals the square root of 9, which equals 3. So that's minus 4 times 3, and that equals negative 12. And so we're just going to pop negative 12 into the bottom of our expression here in the denominator, and then I just want to simplify this down. So the numerator is still exactly the same, but the bottom, we could cancel out the plus 8 square root of 3 and the minus 8 square root of 3, and then 16 minus 12 will give us 4. Okay, and you may think this is the final step, but there is one thing that we can do. We can see that this is completely divisible by 2. We can divide this part by 2 and this part by 2, and therefore also the denominator by 2. So if we divide it all by 2, that will give us 2 plus the square root of 3 divided by 2. And then that gives us our final answer.